And today's project is to make a UVA flashlight out of partial recycle and the rest new components. I currently have this one, bought from AliExpress. It's not too bad, it's good for stuff up close. I have this one also that I also bought a long time ago, and it's not very bright actually. So what I'm going to do is take an old ever-ready 6-volt flashlight and recycle it. These things were ridiculous. It was cheaper to buy a whole new flashlight than it was to buy the battery. So needless to say, there's lots of these laying around. They don't have any recycle codes on them, so they're basically garbage. So at least this one won't be going into the landfill. So I'll be taking it, mounting a power bank, 4,000 milliamp from Canadian Tire. Bought this dirt cheap, $9.99. It has 2 connectors. That's for charging it, and that's the output. So I'll use this for powering the LEDs. Then I'll have a cable connecting from here to the back where I'll mount another connector, USB connector, for charging it with a wall wart. But I'll need this for mounting the LEDs, and the rectangle does not fit in the round hole. So, needless to say, I shall take this, a nice whoop, get it over there, put you like this, around I go with a magic marker, and presto, it's now in a form that I can use. I'll take this out to the bandsaw, cut it out, and then I'll make sure it fits, and if it doesn't fit, I'll just keep trimming until it does. Back in a moment. So, circuit board meets bandsaw, bandsaw wins. Then I did a tiny bit more smoothing with a sander. Now let's just see how well this fits in here. I don't believe it's gonna, now it's still a bit too high. So I'll just take it back out and do some trimming. Where's an LED? Yeah, that looks, even once I get it all glued in there, that's just a touch too high. So it looks like you need to take out about a round of holes all the way around. So, as I say, I'm back in a minute. Okay, this is a try number 2. Yeah, that's much better. It's deeper down. Yeah, that's good. Okay, and on to the next step. So after populating it with the LEDs, now a problem of flipping it over and soldering all the anodes so that it holds in place. So I'm going to do it on this. Take a circuit board, stick it on top, grasp it firmly, flip it over, and hopefully everything's sitting upright. Looks good. Also check to make sure there's nobody got put in backwards. Yeah, that looks good. I'm not going to bore you with the soldering of this part because I'm crappy at soldering. Once one of the leads is soldered, I adjusted the LEDs so that they're more or less straight. Then a matter of just soldering the other lead on each of them. I won't do the snipping yet because I want to attach wires and then the resistors using my nice old Wellner soldering iron and some high quality lead solder. So at this point I've got just the anodes all connected, and I'm just going to do a quick 100 ohm resistor and 5 volts on my power supply. A check. Last thing you want to do is do your final bit of wiring and find out something either came in defective or you made it defective. And if you see my soldering, I might have spent a bit too much time on a few of them. Because one thing with soldering is, it's best to do it perfect the first time. And now, it is time to clip off all of the anodes. Let's see if I can try to keep it in focus. This will at least clean up the amount of space I have in there to work with my big fingers. And when you're doing this, make sure you have glasses on, because these things, if they get away from your finger, would hurt a lot. Okay, that side's done. You've got to protect your eyes. You only have 2 of them, and they're not exactly replaceable. Yeah, that's better. Easier to work on now. One moment, please. Well, time to test it. I've got my power supply hooked up at 5 volts. And what do we get? It works. And comparing that to my little flashlight, not bad. Interesting on the pen. Pen is very yellowish. So here's my fantastic soldering job. I don't think I'll get a job in a Chinese factory, considering how long it took me to put that together. I've attached 2 additional wires coming out so that it just gets fed through here. And then attached in there. It's a simple circuit, 5 volts, light emitting LED, which runs at around 3.2 volts, a 100 ohm resistor. So when you take that all into the calculation, it works out to be about 17 milliamps times 24 of these. So you then get a fair bit of light coming out. One wire gets attached up to the switch. The other wire coming out the switch gets attached up to this cable here. It will be cut, which then goes over to the battery. The other cable gets attached there, and everything gets hot glued in there. But since I don't want to be pulling this thing apart every time I charge it, what I'm going to do is the other end of this, which actually came with this, goes into the charge circuit, and I then just take this over to a nice little breakout, micro B breakout board, and I somehow mount that in there, and you can guess, hot glue again. Very nice invention, hot glue. So I'll now assemble it. So partway through the assembly, I came to realize, of course, is that these wires are so fine that I'm better just tape everything nice and tight. One moment. So this gives some rigidity to it and less likely to break those little wires. And now I can test it to make sure everything's working. Yep, that's working. So I can now move on to the micro B connector. And out comes a Dremel tool. And it's a real one. I'm not going to turn this on. You don't want to hear it. And it's now complete. I deleted by accident the section on all the hot gluing, but as you can see, it's a fantastic job. I made sure I didn't get any hot glue up into this section in here because these connectors actually have kind of two little inserts or extrusions that need to go into those inserts to make it fit. On the inside, I did hot glue it extensively. Is it watertight? Probably not. But I'm not going to be taking this out in the rain anyhow. So now, for charging it, I just plug this in here, take this other end, stick it into a wall wart, and I can charge it up. I figure with the current draw and the 4,000 milliamp power bank, it's good for about 10 hours before it needs to be recharged. And to show that it works. Now, this was a 24 LED one. It's now a modified 23 LED one because I must have snapped a resistor or a lead and there's one that's not working. Oh well, that's life. Have a good day.